So once you've finished designing your car, you want to test it and put it in a wind tunnel and make some guesses about what it is that you could change to improve your design. So first thing you're going to do is export your model out. So just right click on the top of the tree and just go down to Save as Mesh. And you want to save it as an STL binary file. Unit type should be 1 millimeter and refinement should be high. And you're just going to output this. I'm just going to save it onto my desktop. Just going to remember the file name. Just save it somewhere you know you're going to remember. And the reason why we're exporting it out is going to use a different software package to analyze it and do the testing. And that software package is called Flow Design. So it's got an icon which looks like this on your desktop. Put it in. Now this is actually a discontinued piece of software, but I still use it because other software packages like CFD significantly more advanced. It takes a lot more to get your model in and tested and get a number out of it. I figure this is a lot quicker and easier to use and will give us results just as quickly, and we can compare and make changes. And for the application that we need for, I think it's much more appropriate. But it is discontinued, so it does mean that it is a little bit old and not so pretty. But that's what it is. So import from local. As I said, I saved it on my desktop. If I can find it now. Now, what it almost always does is put it in at the wrong angle. So there's a bunch of things we need to change first. Now, this little dot here represents the front and bottom of your design. So first thing we need to change is our orientation. And it's a little bit of guesswork usually. So it's come down on the X. And it also needs to come on that angle. Okay. So we've rotated it so it's at least facing the right direction now. And one thing we do want to set up is our wind tunnel. Where it says wind tunnel. Now, there's a couple of things we need to change in here. One is wind speed. So by default is 10. We want to change that to 20. And the other thing we want to change is we want to resize the tunnel itself. So right over here, there's a little cross and a drop down. You want to change this to orthographic. If it's in perspective mode, it's really difficult to align up. But first thing we want to happen is we want wheels on the ground. So you want to lift up the bottom of the box. You can probably drop the height of it. It doesn't need to be that tall. And you want about 2 car lengths in front of your car and about 3 behind. Now, I wish you could do this a bit more accurately. But when you do this, over here, it will show you the length, the width, and the height. It should be around about 1 meter long. When you're doing this testing, you want to make sure it's always the same. You want to make sure that your box is pretty close to identical each time. So I've set up my wind tunnel and set up my orientation. If this is in 2D mode, you want to change it out and switch it into 3D. And just make sure you've got the same ones that I've got up here, velocity. We will actually turn our drag plot on because that is going to be where all the information is, or a lot of the information is. And it's a bit of a graph here. When it starts the simulation, it starts up really high, the drag coefficient, and then it drops over the course of the next 10 minutes. You'll get to a point where it drops off really fast and it will dive, and when it hits the bottom of that, it sort of levels out and then it will give us a result. So currently it is still calculating. Up the top right here, it says the status is transient, so it's still figuring out what the result is. It'll get to a point where it's stabilized, and that will be an accurate number. So currently my drag coefficient isn't very nice, it's not very pretty, but that number is going to drop. It's still not going to be amazing, but it'll be okay. It'll be a starting point for my process. sort of anything under 0.2 is a good number. So 0.2 or thereabouts. So at the moment, it's showing me the velocity in meters per second of pressure around the car. And you can shift that around. If your car isn't colourful like mine, you haven't got your surface pressures turned on. So you want to make sure the surface pressures are turned on in your car. It's handy by itself, the surface pressures, because you look at it and you can see what areas of the car have got really high pressure pushing against it. Now, you're always going to get this part of your wheel is always going to be bright red. So there's no way of preventing or stopping the air from hitting that, and always the front edge of your car is going to be bright red. So something has to hit the air first. It's just but you can look at other areas of the car and see what you could change. So what I generally say is anything which is extreme, like deep red or dark blue, is usually bad. You want to avoid extremes. So obviously, really high pressures you want to avoid, and then really low negative pressures. So negative pressures tend to suck back on the car, and positive, like high positive pressures, push on the car. So push back on the car. So you want to try to avoid those extremes and try to get the car in these middle zones as much as possible. Now, I'll preface everything. I should have said this to start with. I'll preface everything by saying I'm not a physics teacher. I can make some guesses around what you can change, but this is something you might want to take to your physics teacher to get some proper analysis on. So this plane through the middle you can shift, and you can see what the pressures are like in different areas around the car. You can even change this sort of sideways so you can get different ideas of what the air is doing in different parts of the car. Generally, what I would look at is this flow behind the car. So this blue space, as I said, that's sort of sucking back on the car. All this dark blue stuff is negative pressure and it's pulling the car backwards. So what you want to happen is allow a little bit of air to come underneath, just like you can see on mine. It comes underneath, and you're trying to make this blue wake, which is behind your car, as little as possible. So to be sort of a feather out like a triangle behind your car, rather than it being a big block. So as little as possible on your wake. What I've found is allowing air to come underneath is usually a good thing. You also see these sort of little rooster tails around the place. And what I've found that is basically the air ramps up and then sort of creates turbulent air in these sorts of places. So smoothing these surfaces out, making this less of an angle here, can sort of assist reducing those rooster tails. See now my drag plot is starting to drop fairly rapidly. So this is sort of the beginning of the end. It should be finished fairly soon. It can take up to 10 minutes depending on the computer you're using as well. Currently we're using a plane to analyse the design. There's also flow lines you can use, so you can turn your flow lines on and see what's happening around the car. You can change the settings of these. If you go to settings, you can change how many there are or what types there are, if it's smoke or if it's lines or if it's tubes. It looks really cool, but I haven't found it as useful as having the plane, to be honest. Where it does come in handy is it will show you where there's sort of vortexes and turbulent air. It shows you that stuff a little bit better. So lines are kind of cool, but I found that the plane's probably more useful in terms of analysing the things which are going on in your car. Also, don't forget to drag it off to one side and check out what's happening over the side pods and that sort of stuff. So you might be able to see maybe this side pod's a little bit low, maybe I could pick it up a bit higher and maybe it will have a better effect on the car. So what I want to see is you look at these results and make some sort of educated guesses about what you could change and sort of justify what you're changing and why. So if let's say maybe changing those side pods would be a good idea. Maybe that's something I'm going to do. Maybe I'm going to flatten out, make some of these curves on my body, make them a bit flatter, sort of in an attempt to remove some of these things, these rooster tails. So maybe I'll do those. I'll go back to Fusion. I'll make my changes, export out again, and retest. What I'd recommend you do is make sort of one change at a time. If you make 3 or 4 changes in one shot and then bring it back in, you don't know what worked and what didn't work. So try to be a little bit more considerate about your approach, but make your change, come back into Flow Design and see if it worked. Now, it could make it worse. Having your car slammed right against the ground, and you could pick it up, and it could be a worse result. I'm not a physics teacher, so I don't know enough about what to change and why, but you can sort of draw some conclusions from what you see, make the changes, bring them in, and hopefully they will improve your design, and you can sort of slowly develop your design from there. So you probably want to bring in a few different changes, 2 to 3 or 4 different changes, and see what that happens there. So my status is finally stabilized. I'm at 0.33. It's not an amazing number, but it's not terrible. So that will do for this example, I think. So once you've made your changes, refine your car design. Make sure you document everything in your folder or in the class notebook.